Welcome back to Cosmos in a Pod Space and Astronomy series. It's amazing to think that out there in the universe, there are objects shining brighter than an entire galaxy.
Yeah, it's pretty hard to wrap your head around.
It really is. I mean, we're talking trillions of stars worth of light, all packed into a space smaller than our solar system.
It's crazy.
It really is. Sounds impossible, right?
Yeah, you wouldn't think it's possible.
Well, that's the mind-boggling reality of quasars, the cosmic lighthouses we're diving into today.
Yeah, quasars are they're fascinating objects and they really push the limits of what we thought was possible in the universe.
So let's break this down a bit.
Okay.
What exactly is a quasar? I mean, quasi-stellar object. It sounds like something straight out of Star Trek.
Yeah, it does have a kind of sci-fi ring to it.
It really does.
Well, the name actually comes from how they were first discovered. Astronomers were looking out into the universe and they saw these points of light that looked kind of like stars, but when they studied the light more closely, it was way off.
What do you mean way off?
I mean, the spectra, the fingerprints of the light, they were unlike anything they'd seen before.
Oh, so it wasn't just regular starlight.
Nope, not at all. So they call them quasi-stellar objects, basically. Star-like, but not quite.
Okay, so like cosmic imposters then. They look like stars but are hiding something much more intense.
Exactly. And what they're hiding is a supermassive black hole, millions or even billions of times the mass of our sun.
Whoa, hold on. Black holes are supposed to be black, right? They suck everything in, even light.
Right.
So how can they be the source of so much light, so much energy?
Yeah, that's the part that really blows your mind. See, when matter falls into a black hole, it doesn't just disappear quietly. It gets whipped around at incredible speeds, forming this swirling disk around the black hole.
Like a whirlpool.
Exactly. It's called an accretion disk. And as all that matter swirls around, it gets heated up to millions of degrees.
Just from friction.
Friction and the intense gravitational forces, all that superheated matter emits a ridiculous amount of energy across the entire electromagnetic spectrum. From radio waves to gamma rays, it's like the ultimate cosmic light show.
So it's not the black hole itself that's shining, but the stuff falling into it. It's like the black hole's last meal is putting on a spectacular performance before it's gone forever.
Yeah, that's a great way to put it. And that performance is incredibly efficient at converting matter into energy. It makes nuclear fusion, the process powering our sun, look like a firefly compared to a supernova.
Okay, now that is just mind-blowing. So we've got these supermassive black holes surrounded by glowing, swirling disks of matter. But how did we figure out that it was black holes behind all this?
Well, it took a lot of detective work. Scientists saw this incredible energy output coming from an unbelievably small area.
Right.
And they knew that the only thing that could pack that much mass and energy into such a tight space had to be a supermassive black hole.
It's amazing how we can piece together these cosmic puzzles from, what, billions of light years away?
It is. It's really remarkable what we can learn from the light that reaches us.
Absolutely. But here's another puzzle. How did those supermassive black holes form in the first place?
Yeah, that's one of the biggest mysteries in astrophysics. We know smaller black holes form when massive stars die and collapse under their own gravity.
Right.
But supermassive black holes are a different breed. They're millions or even billions of times more massive.
So how do you go from a regular-sized black hole to a supermassive one? Is it just like a cosmic growth spurt? Do they just eat a ton of stuff?
Well, there are a few ideas out there. One theory is that they start small and just gobble up a ton of matter over billions of years.
So they're just constantly eating and growing.
Yeah, like a cosmic vacuum cleaner on a never-ending feast.
That makes sense.
Mm-hmm.
But is there another way? Could they maybe, like, skip the whole growing up phase and just form as supermassive black holes right from the get-go?
Yeah, that's another possibility. Some scientists think that in the very early universe, right after the Big Bang, giant clouds of gas could have collapsed directly into supermassive black holes.
Whoa, so they just kind of popped into existence fully formed.
Potentially, yeah. It's still a bit of a mystery, but either way, you end up with these behemoths lurking in the hearts of galaxies.
So we're not entirely sure how they form, but we know they're there, powering these crazy bright quasars. But, here's another thought. If these quasars are so bright, can't we see them from really far away?
You're catching on quickly. That's exactly right.
Okay, cool.
Because quasars are so luminous, we can see them across vast cosmic distances.
Like how far?
We're talking billions of light years away. When we observe these quasars, we're literally looking back in time.
Wait, so we're seeing these quasars as they were billions of years ago? Like a time machine?
It is like a time machine. It's pretty incredible.
So what can these ancient quasars tell us about the early universe?
They give us clues about a time when the universe was much younger and more chaotic, a period called the Epoch of Reionization. Imagine the early universe as this fog of neutral hydrogen. Quasars were like cosmic lighthouses blasting through that fog, stripping electrons from the hydrogen atoms and making the universe transparent to light.
So these quasars weren't just shining bright, they were actually changing the very fabric of the early universe.
That's right. They were clearing the fog for stars and galaxies to form as we know them today.
That's amazing. But hold on. How do we even find these quasars in the first place? They're billions of light years away.
Well, it's definitely a challenge, but we've got some pretty clever tools to help us. One of the main ones is something called redshift.
Redshift.
Yeah, imagine the universe as like a giant balloon that's expanding.
Yeah.
As light travels through this expanding space, its wavelength gets stretched, shifting towards the red end of the spectrum.
Okay, I think I'm following. So the farther away a quasar is, the more its light is stretched, the redder it appears.
You got it. And quasars are so far away their light can be extremely redshifted. By measuring that amount of redshift, we can calculate how far away the quasar is, and that tells us how far back in time we're seeing it.
Wow, so redshift is like a cosmic yardstick, helping us measure the vast distances to these quasars.
Exactly. And besides redshift, quasars have these unique fingerprints in their light called spectral lines.
Fingerprints.
Yeah, specific patterns of bright and dark lines that tell us about the chemical composition and the movement of the material swirling around the black hole.
So redshift tells us how far away they are, and their spectral fingerprints confirm that they are indeed quasars.
That's right. It's amazing how much information we can get from light that's traveled for billions of years.
It really is. Okay, so we've talked about what quasars are, how they form, how we find them. But are there any, famous quasars out there? Any that really stand out from the cosmic crowd?
Oh, absolutely. There's 3C273, for example. It was the first quasar ever discovered back in the 1960s.
The OG quasar.
You could say that. It's still one of the brightest we can see from Earth.
Wow. What about, some of the more distant ones, the ones pushing the limits of what we can observe?
Well, there's this one, ULAS J1342 plus 0928. It's the current record holder for the most distant quasar ever found.
So how far back in time are we seeing that one?
We're seeing it as it was just 690 million years after the Big Bang.
Wow. It's like peering into the universe's infancy. Okay, I gotta ask, any real heavy hitters in the quasar world?
Ooh, you want a heavy hitter? Let's talk about TON618. This one's an absolute monster.
Good boy, here we go.
Remember how we talked about our sun being big? Well, imagine a black hole over 66 billion times more massive than our sun.
That's just incomprehensible.
I know, right? That's what's at the heart of TON618, a hyperluminous quasar that puts everything else to shame.
66 billion times the mass of our sun. It's like comparing a grain of sand to Mount Everest. Okay, but here's a question. Are quasars just loners out there in the vastness of space, or do they have any companions?
That's a great question, and it leads us to the fascinating relationship between quasars and their host galaxies.
Okay.
They're not just isolated phenomena, they're embedded within galaxies, and they have a huge impact on their surroundings.
Interesting. So it's not just the galaxy providing fuel for the quasar, but the quasar is also influencing the galaxy.
Exactly. It's a complex dance between the quasar and its host galaxy, and that's what we'll explore further in this deep dive.
Well, I'm definitely ready to keep dancing with this topic. It's captivating.
It is, and there's so much more to uncover. So, we've talked about how quasars are fueled by these supermassive black holes gobbling up matter.
Yeah.
But it's not exactly a clean and tidy process. It's more like a cosmic food fight with energy blasting out in all directions.
Okay, so it's not just light pouring out then.
Yeah.
What else is going on in this cosmic free-for-all?
Well, think of it this way. As the black hole devours all this matter, it releases these incredibly powerful winds and jets of particles.
Oh.
It's not just a light show, it's a cosmic hurricane, this torrent of energy that can actually push gas and dust away from the black hole.
Whoa, hold on. So the black hole, this thing with insane gravity pulling everything in, is also pushing stuff out at crazy speeds.
You got it. It's like this cosmic tug of war.
It really is.
And these outflows of energy, these cosmic winds, they can have a huge impact on the galaxies surrounding the quasar.
So what kind of impact are we talking?
Well, they can actually blow gas and dust away from the black hole, sometimes even out of the entire galaxy.
Seriously?
And here's the kicker. That gas and dust is the stuff that new stars are made of.
Oh, wow. So the quasar is basically pushing away its own food supply. It's like it's on a diet, but it's blowing its food across the whole galaxy.
Yeah, that's one way to think about it. And this whole process, it's called feedback.
Feedback.
Yeah, and it plays a crucial role in how galaxies evolve. By pushing away the gassy dust, the quasar can actually stop new stars from forming in its host galaxy.
Wait, so the quasar, powered by this black hole that's supposed to be sucking everything in, is actually preventing new stars from being born?
Exactly. It might seem kind of counterintuitive, but that's the beauty of astrophysics. The universe is full of these unexpected twists and turns.
It really is, yeah.
And this feedback process actually helps explain why we see fewer quasars in the nearby universe.
Oh, how so?
Because they've already blown away their food supply, they've dimmed down, gone quiet.
I see. So all those seemingly peaceful galaxies we see around us today, they might have had a wild quasar-powered past.
Precisely. We believe that most, if not all, big galaxies have gone through a quasar phase at some point in their history.
Wow. So they've had their crazy, energetic youth, and now they've settled down into a more, I guess, mature, quieter state.
That's a great way to put it.
It's amazing to think that these incredibly distant, incredibly powerful objects can tell us so much about the galaxies around us, even our own Milky Way.
Yeah, it really highlights how interconnected everything is in the universe.
It does, yeah. But as much as we've learned about quasars, I'm sure there's still plenty of mysteries that keep you guys up at night.
Oh, absolutely. There's always more to learn, more to discover.
Okay, so lay it on me.
Yeah.
What are some of the big questions that still puzzle scientists about quasars?
Well, one of the biggest head scratchers is how supermassive black holes grow so quickly in the early universe. Remember those distant quasars we were talking about? The ones we see just a billion years after the Big Bang?
Yeah.
They already have black holes billions of times the mass of our sun.
Yeah, that's crazy. How did they get so big so fast? I mean, is there some kind of cosmic growth formula we're missing here?
That's what we're trying to figure out. Our current models really struggle to explain how those black holes could have packed on so much weight in such a short amount of time.
Right.
It's like finding a dinosaur skeleton in a kindergarten playground. It just doesn't fit the timeline.
I love that analogy. So there's something fundamental we're not understanding about how black holes form and grow in the early universe.
It seems that way, yeah. It's one of the most active areas of research in astrophysics right now.
I bet. Okay, so what about the trigger for a quasar to switch on in the first place? We talked about galaxy mergers,
Right.
but is that the only way?
Well, galaxy mergers are definitely a major player. When galaxies collide, it can send a huge amount of gas and dust spiraling toward the central black hole, fueling that quasar outburst. But it might not be the only way.
Okay.
We're also looking at other possibilities, like instabilities within the galaxy itself,
Oh, interesting.
or even interactions with nearby galaxies, things that could sort of kickstart that quasar engine.
So it's not a one-size-fits-all situation.
Right.
It's more like a cosmic recipe with multiple ingredients that can lead to a quasar lighting up the universe.
That's a great analogy. And we're still trying to figure out the exact recipe, the sequence of events that leads to a quasar switching on and then eventually fading away.
Right.
It's like we've got this puzzle with a few pieces still missing,
The mystery continues.
but we're getting closer to the full picture all the time.
It's exciting to think there's still so much to learn about these amazing objects.
Absolutely. Quasars are like windows into the most extreme environments in the universe. They're pushing the boundaries of what we know about physics and the cosmos.
And they're just so cool to think about.
They really are.
I mean, so to sum it all up, quasars are more than just bright lights in the distant universe.
Right.
They're these powerful engines of galactic evolution.
Yeah.
They're shaping the galaxies they inhabit, and they're giving us clues about the very early universe.
It's incredible, isn't it?
It is. You know, it really is mind-blowing when you think about objects so far away being able to tell so much about the universe we live in.
I know. It's incredible, isn't it? The sheer scale of it all. These quasars fueled by black holes that could, swallow our entire solar system without even a hiccup. And they've been shining their light across the cosmos for billions of years.
It's humbling, almost. Like we're just these tiny specks trying to understand these forces of nature that are just so immense. And it makes you wonder what else is out there.
Absolutely. And, that's what keeps us going as scientists, that constant thirst for knowledge and understanding. Every new discovery just opens up even more questions and pushes us to re-examine what we thought we knew about the universe.
I'm glad you mentioned that because I think back to when we started this deep dive into quasars, I thought they were just these, bright lights in the distant universe.
Right.
But now I realize there's so much more than that. They're these powerful engines of galactic evolution, shaping the galaxies they inhabit, and they're giving us these invaluable clues about the very early universe.
Exactly. They're like time capsules, carrying information about the universe's past, a time when everything was so much more energetic and chaotic.
And who would have thought that these seemingly destructive objects, these black holes, could actually play such a crucial role in the birth and growth of galaxies?
I know, right? It's a great example of how the universe is full of these, unexpected twists and turns. It's full of paradoxes, and that's part of what makes it so captivating, I think.
I couldn't agree more. And for everyone listening out there, I really hope this deep dive has sparked your own curiosity and wonder about the universe and our place in it. It certainly has for me.
Me too. And if you're eager for more of these mind-blowing explorations of the cosmos, be sure to subscribe to Cosmos to a Pod wherever you get your podcasts.
And hey, while you're at it, check out our YouTube channel for even more cosmic content, including stunning visuals and animations that will bring these incredible objects to life. Until next time, keep looking up and keep exploring.